Emostel.
Hello, you're welcome to this video. And in this video, we continue from where we stopped the last time. So if you're just joining this video and you don't know where we started from, please you can just check the channel and then you will see the other videos that is connected to this particular video. All right, so let's just proceed. In this video, we are going to be talking about some basic operations on sets. Now, the first operation we are going to consider is the difference of sets. Well, when you say that is set A, when you have a question that says like A difference B, A difference B simply means we are looking for the set of all elements present in A but not in B. So if I write something like this, if I say, you're talking about difference of set now. Okay, in the previous video we discussed that the difference of two sets is represented by this minus sign or by a bar between the two sets. Some textbook may write it as A then /B. Okay, they all mean the same thing, just trying to tell you find the difference of the two sets. All right, so the difference of the two sets is the set of all elements present in one but not in the other. So if set A, for instance, is equal to 1, 2, 3, 4, 5, and then we have set B is equal to 1, 3, 5, 7, 8. Okay, so we have two sets like this, and then the question says find 1, A difference B, and then find 2, B difference A. Okay, all right, so if you want to get this, all you just need to do is to check the two sets. What are the things that you can find in A but you cannot find in B? So when you check them out, you will see A has 1, B has 1. A has 2, B does not have 2. So you write it out, we have 2, comma, if you check, both of them have 3, okay, but there is 4 here, there is no 4 here, so we have that. Then the next one, this one has 5, this one has 5, okay, so apart from 2 and 4, there is no other set left, okay, because A ends at 5 there, and then we've checked every element of A. So these two elements are the elements that can be found in A, but not in B. All right, on the other hand, we have B difference A. B difference A is a set of all elements that can be found in B, but not in A. So what are the stuff that we can find in B, but not in A? 1 is here, 1 is here. So 3 is here, and 3 is here. 5 is here, 5 is here. 7 and 8 can be found in B, but not in A. So we have it like 7 and 8. All right, so as you can see now that A difference B is not the same result as B difference A. So which simply means that the difference of two sets is not commutative. Okay, so if A, so you say, okay, since A difference B is not the same thing as B difference A, okay, then the difference of sets is not commutative. Okay, so all right, so that is that as per the difference of sets. Now we move on to the second one, power sets. Well, the power set, as explained in previous video, is a set of all the possible subsets that can be found in a given set. All right, so if I have set A and I say A is 1, 2, 3, I'm going to repeat the same example as before, okay? Because there is something special I want to deduce from this. Okay, so if you have A is equal to 1, 2, 3, which means we have 3 elements in set A. And then we need to find the power set A. Like the question says, find the power set of A. Very simple, it's fine. So what you do is that you check for all the possible subsets that can be formed from this particular set. Well, the first subset that can be formed, let's just say the empty sets. Since the empty set is a subset of all sets, as discussed in previous videos. Okay, so then we say the empty set is one of the subsets of this A, right? Another subset of A, let's say A2, is a singleton one, which means a set that has only one element. And then in this case, let's say 1 is that one element. We can also form another singleton set from A as A3, okay, as a subset of A, a singleton 2. We can form another subset of A as singleton 3, okay? Now, we could also get the other subsets too, like let's have this one as A5. Another subset that can be formed from A is a set that contains 1 and 2. Another subset that can be formed from A again is a set that contains 1 and 3. Please mind you, if I say 2 and 1 is the same thing as this. If I say 3 and 1 is the same thing as this. The position of the elements does not matter. What matters is the presence of the elements. Do you understand? So the position does not matter. It is the presence of the elements that matter. So if I say 1 and 2 and I decide to write 2 and 1, they are the same. So don't take 2 and 1 as another subset. No. The fact that 1 is here, 2 is here, then that is all for anything having to do with 1 and 2 as far as the story of this set, whatever, is concerned. Okay? Now, so the next one, A7, we can form another set that contains 2 and 3. In the previous video, I did not include this 2, 3 in the video where I first explained power sets. And that was an omission. Please, I'm very sorry about that, but you can correct this in this video now. Okay, so 2 and 3, okay, is another possible subset that can be formed from this set A, which contains 1, 2, 3. All right, and then the last subset that we can form, because there is no other one. You know, we started from the empty set, we continued with the singleton 1, singleton 2, singleton 3. And then we continue with 2 sets, okay, 2 elements, 2 elements, 2 elements. Then we cannot have another 2 elements subset anymore, okay? So we can only have 3 element subsets now, okay? And which happens to be the same set A itself, which is 1, 2, and 3. Since every set is a subset of itself. So the very first one was formed because the null set, the empty set, is a subset of every set. Why this last one is formed? Because every set is a subset of itself. Okay, we've discussed this in some videos we did before now. All right, then the other ones were formed, you know, because I'm out of juggling between the elements of the sets. This is a singleton set, a singleton set, a singleton set, otherwise called the unity set. All right, the empty set, which can also be called the void set or the null set. It has 3 names: empty set, void set, null set. They're all the same. Okay, so at the end of everything, then we have we can see that we have a total number of 8 subsets formed. We have 1, 2, 3, 4, 5, 6, 7, 8. A total of 8 subsets formed, and that is because A is a set of 3 elements. There is a general formula for power sets, okay? The formula says that if set A contains n elements, if set A contains n elements, when I say n elements, it means it contains n number of elements inside it, okay? In this case now, n will be equal to 3 because set A contains 3 elements. If set A contains 4 elements, then n will be equal to 4. If set A contains 5 elements, it means n will be equal to 5. N stands for the number of elements present in a given set. So the formula says that if set A contains n elements, it says then the power set of A will contain 2 raised to power n number of subsets. Okay? If A contains n elements, then PA, that is the power set of A, will contain 2 raised power n number of subsets. So in this case now, where n is 3, because n contains 3, because the set A contains 3 elements in this particular case, then you have what? You have number of subsets that can be formed from A is 2 raised to power 3, because n is 3 now, then that is what? 2 times 2 times 2, which is equal to 8. And that is the reason why we have 8 subsets here. So we can just play with something. Let's assume that n is 2. Okay, let's say we have a set. Let's say we have a set like let's say set B is equal to X and Y. If set B is equal to X and Y, so how many subsets can we form from set B? Remember, the very first one is going to be the empty sets. The next one, okay, the next one is going to be set singleton X. The next one, singleton Y. And then the last one is X and Y itself, because every set is a subset of itself. Then we cover it. This is the first brace, this the last brace. Then the other ones are sets in between. Like this is a set of sets. Okay? So power set is always a set of sets. Because it's a set of all possible subsets that can be formed from a given set. Okay, so at the end of the day, what do we have here? We have 1, 2, 3, and 4. We have 4 subsets formed. Why do we have 4 subsets? Because B contains, we have 4 subsets because B contains 2 elements. And then, you know, in this case, now n will be equal to 2. So we have 2 raised power 2 is equal to what? 4. All right? Just because we have 2 elements, then we are going to be having 4 subsets. So that is the characteristics of power sets. All right? So that is the end of that topic. Okay? That section, power sets. If you don't understand, please, because I'm really talking very fast, I want to cover all of these things in the video, and I don't want the video to be that long. Okay, so we move to the next one, which is the intersection of sets. Well, the intersection of 2 or more sets is a set of all elements that are common to all those sets. Okay, so which means that if I can find set A, if I can find an element in set A, and I can still also find the same element in set B, then it means that element is an intersection. Okay, it's like it's one of the elements that intersect between the 2 sets A and B. You get it now? So, but then it is not only one; it can be more than one element that could be common to 2 or more sets. Okay, but above all, the number of elements the elements that are common, or the set of elements that are common to 2 or more sets, is what we call the intersection. Okay, let's play with an example here. For intersection, let's say A is equal to 2, 3, 5, 7, 4. The order of arrangement does not matter. Okay, so we have set B. Let's say 1, 2, 3, 4, 5. Okay, and then intersection of set is usually represented by this n thing. We've talked about that before. So if the question says find A intersection B, if the question says find A intersections B, then it simply means that we're looking for all the elements that are common, that is common to A and B. So what we can find in A that we can also find in B. All right, so to do that, when we check, 2 is here and 2 is here, so 2 is common. 3 is here, 3 is here, 3 is common. Well, 5 is here, 5 is here, 5 is common. 7 is here, but 7 is not here. So 4 is here, 4 is here, then 4 is common. So at the end of the day, A intersection B is a given set 2, 3, 4, is a set that contains the elements 2, 3, 5, and 4, because these are the elements common to the 2 sets. So intersection does not only occur between two sets, it can occur between even up to 3 sets or even more. What matters is the fact that some elements are common to those sets involved. I believe you get that. So intersection, like letter N, intersection, letter N. Okay, so this thing looks like N, okay, like one inverted, U and O. So it's represent the intersection of sets. All right, from intersection, then we quickly move to union of sets. Before I talk about disjoints, I'm going to talk about union first. Okay? Okay, don't worry. Let me talk about disjoint first. You get why? All right, so to talk about disjoint sets, the disjoint set is just a set that does not have, well, like when two sets are disjoints from each other, it means they do not have any intersection. Okay? So which means if I have set X as A, B, C, and I have set Y as D, E, F, okay, then it means that, okay, X intersection Y is a null set, or you can say X intersection Y is empty, okay? All right, so you can, the reason why it's like that is because no elements are common between the two sets. Nothing is common. They don't share anything in common. So that is the reason why the intersection of the two sets is empty or null. Okay? So that is for that. So when two sets don't have any elements in common, it means they are disjoint sets. Then from then we move on to the union of sets. Union of sets. Okay? Now, if we consider union of sets, the union of two sets or more than two sets is just a combination of all the numbers, a combination of all the elements, the combination of all the elements in the set is what we call union. All right? So when you have set A as this and set B as this, then it means that the union of A and B, okay, I'm referring to this set now. So A union B is equal to the combination of all the elements of A and the elements of B into one set. Union. Union means we join together, okay? And then the letter U also helps us to remember that. I believe you understand that. So when you check the two sets, just bring everything together under one umbrella and that forms the union. Okay, but remember, don't forget the sixth rule of sets that we discussed in one of our previous videos. The sixth rule says that under no circumstance should you repeat any elements. So which means that nothing must be repeated. Even if the elements are common to the two sets, you don't repeat. So now let's go. We have 2 here, right? Okay, we have 1. You can scatter the arrangement, it doesn't matter, okay? But then let us just try to be civil. So let's try to arrange it so we don't omit anything. We have 1, okay? There is 2 here, there is 2 here. It's only one of them you write, okay? If I'm offering physics and I'm also offering chemistry, okay? So which means I'm taking physics, like I register for physics and I register for chemistry. And then something happens and they say, okay, everybody, if you know you are doing physics, come here. If you know you are doing chemistry, come here. You know, I belong to the 2. All right, then if the person says, okay, no, you know what? Everybody doing physics and everybody doing chemistry, we want to put you all together. Now, doesn't mean that because I'm doing physics and chemistry, then I will double myself. No, I will still remain the same entity, only that I am taking the 2 courses and then they combine the people doing the 2 courses together into one. Okay, so I cannot repeat, I cannot be more than this same Emmanuel, even despite the fact that I belong to the 2 sets. So if they are to combine the 2 group of people, it is still me, the same me alone that would be represented. I mean, that would be representing me in that combination. So the same thing applies here too. So there is 2 here, there is 2 here, it doesn't matter. It's only this one same 2, okay, that we represent. Then we have 3, okay, and then we have 4, 4, but no problem. We have 5, we have 7. I don't think I omitted anything. Okay, so this is a combination or the union of set A and set B. So, and that settles this. Now we move on to the sixth stuff, which is the complement of sets. But there is no way we can explain the complement of sets without involving a universal set. This topic, complements, it's attached to universal sets. Okay, so now let's quickly create an example having to do with universal sets. Let's say A is a set of X such that X is even. Okay. All right, let's say A is a set of X such that X is a natural number. Okay, A is a set of X such that X is natural number and 0 is less than X, less than or equal to 20. Okay, all right, so which means there is a set. I can call it a universal set because I want to create some other sets under it. A universal set is a set that has other sets created from it. Okay, so every of the sets created from it, they are subsets to the universal set. But then it has other sets, but it's not like those sets created from it, okay, must not be from another set. They all must be under the control, like under the domain of the universal set. So anything I'm going to create below this universal set, whatever the instruction is, I'll make sure that all the elements are formed from this universal set. For instance, you have been given a general set, right? And then you now say, okay, let A be a set of P such that P such that 0 is less than P and then less than 10. All right, and then let's say B is a set of Q such that Q is prime. All right, and then C is a set of R such that R is even. R is, or let me say R is odd. R is odd. Okay. Let me change this first example to like A is a set of P such that P is even. Okay, good. Now, we have been given 3 sets under the universal set. Okay, and then the very first set says that we are looking for all even numbers from this universal set. The second set says we are looking for all prime numbers still from this universal set. And then the third one says we are looking for all odd numbers still from this universal set. All right, so none of the elements of the set will be derived from a foreign set. No, since a universal set is given, every other set that follows will be formed from it. Now, if we want to interpret this, we want to interpret it from the set builders form. Okay, you want to interpret it from the this fly disturbing me. You want to interpret this from the set builders form in which it is into a roster form. All right, so what we do now is that we'll just let's interpret it first so that we'll be able to know what to do with those elements. Let's say the question says find number 1 A complements. All right, find A complements. Or let me say find B complements intersection B complement intersection A. Then number 2, find A union B complements. 3, find A complements union B complements. 4, all right, find Okay, find B intersection C. Okay, right, find B intersection C. Find B intersection C. Okay, now if you want to do all of this, it's very simple. So let's just let us just work it out. You have been given the set builders form. The very first thing you do is to interpret the set builders form into the tabular form so that you can be able to know to solve all of these questions from it. It's very simple, just follow me. All right, so if you want to do this, you just say all the even numbers, okay, A is even, so you find all the even numbers between 0 and 20, okay? Right, this description says that the universal set is a set of X such that X is even, which means the universal set is a set of even numbers. But then there is a domain given. The domain says that, yes, we are looking for even, we are looking for natural numbers. This is natural, okay? We are looking for natural numbers, fine. That one is specified, okay? In the question that the universal set is a set of natural numbers, but the domain specified is that we are looking for all natural numbers between 0 and 20, all right? Because when it says universal set is a set of some numbers such that those numbers are natural, all right? And those numbers are greater than 0 but less than 20. You know, if you say 0 is less than X, it means that X is greater than 0. Okay, so the universal set is a set of some kind of numbers such that those numbers are natural, and this comma means and those numbers are greater than 0 but less than or equal to 20. So first and foremost, it means that universal set is going to be something like this: 1, 2, 3, 4, 5. Natural number is a set of all positive whole numbers. Okay, that's when you see this n, it means a set of all possible positive whole numbers. So we have 1, 2, 3, 4, 5. We have 6. We have 7, and everything goes on to 20, like that. Then set A in its own case, we are looking for even numbers within this range. So all the even numbers will be like 2, 4, 6, 8, numbers that can be divided by 2 without remainder. Then we have 10, we have 12, 14, 16, 18, and 20 inclusive. Okay? If you look at this one, it said X is greater than 0, which means X is greater than 0. If 0 is not inclusive. Assuming the thing says equal to 0 now, you might start to consider putting 0 inclusive, but then in 0 is not there, so you start from 1, okay? From the next positive whole number, okay? So that's where you start from, which means 1, okay? All right, and then we have B, this set B. Set B is a set of prime numbers, okay? So if you are looking for prime numbers, what are prime numbers actually? Prime numbers are numbers that cannot be divided by any other number without remainder unless they divide themselves or they are being divided by 1. There are some numbers like that, okay? Well, according to mathematics, the very first prime number is 2. First prime number is 2, okay? Then from 2, you start checking the others. We are looking for some numbers in such a way that those numbers, nothing can divide them without remainder except they divide themselves or they are being divided by 1. But if any other number in this world divides them, there will always be a remainder. The first example is 2. After 2, the next prime number is 3. No number can divide 3 without remainder. Okay? After 3, you know, 4, something can divide 4 without remainder, which is 2, right? So we move on to the next one, 5. 5 is the next prime number. Okay? Then 6, 3 can divide 6. 2 can even divide 6 too without remainder. So 6 is not prime. Then 7 is prime. 8 is not prime. 9 is not prime. 10 is not prime. 11 is prime. 12 is not prime. 13 is prime. 14 is not prime. 15 is not prime. 16 is not prime. 17 is prime. 18 is not prime because something can divide 18 without remainder. 19 is prime, okay, and 20 is not prime. So all the prime numbers between 0 and 20, between 1 and 20 includes all of this. If you see all of these numbers, nothing can divide them without remainder. They will always be remainder, except they divide themselves or they are being divided by 1. Okay, so now we move on to the third one. Let's interpret the third one sharply. The third one says C is a set of odd numbers. So we are looking for odd numbers between 1 and 20, and that would be 1, 3, 5, 7, 9, 11, 13, 15, we have 17 and 19. Okay, good. So we have all of these sets complete, right? So I'm going to wrap up this part. I'm not going to teach this in this video because it's like another word entirely. The video will be longer if I do so. So I'm going to stop at the complement of sets, okay? So in that case, I can wrap up this part so I can use that space to solve question. All right, good. So we have all of these things. We have A, B, and C, right? Good. And then the next thing is to start answering these questions. The first question says, find B complements. Find B complements. Find B complements intersection A. All right, to find B complements intersection A, to find B complement intersection A, well, the very first step is for us to first find B complements. When we find B complements, then we'll know how to intersect it with A. Do you get what I'm trying to say? So now, find B complement first. Sometimes to be written as B with a small c on top, it's still the same thing, okay? Now, the complement of any set, well, is a set of all elements that are present in the universal set, but not in that set, okay? Which means that the complement of a particular set, let me repeat it again, the complement of set B is a set of all elements that is present in the universal set, but not in B. The complement of A is a set of all elements present in the universal set, but not in A. The complement of C is a set of all elements present in the universal set, but not in C. Okay, so we want to find the complement of B. The complement of B first. So B complement is going to be, we check, what is B itself? B is all of this, right? So every element that can be found in the universal set but cannot be found in B is the complement of B. So let's fetch out those elements. We have, the universal set contains 1, so 1 is not here. The universal set contains 2, but 2 is here. It contains 3 and 3 is here. It contains 4, 4 is not here. It contains 5, 5 is here. It contains 6, 6 is not here. The universal set contains 7, all right? So 7 is here in B. It contains 8, but 8 is not here. Then it contains 9, 9 is not here. It contains 10, 10 is not here. It contains 11, but 11 is here. It contains 12, 12 is not here. It contains 13, the universal set contains 13, 13 is here. It contains 14, like 14, 15, 16. We have 14, 15, 16, and then 17 is here. We have 18, 19 is here, and the next one is 20. So at the end of the day, the complement of B is all of these elements that we find here in this particular set. Okay? Now, we now look for the complement of B intersection A, which means we are looking for the element that is common between the complement of B and set A. So what are the elements that can be found in B complement and that can also be found in set A? So what are those elements? Those elements include set A, that's, you know, A is a set of all even numbers. So let's check out, we are going to fetch out all the even numbers present in this place because that would be the elements they have in common. So we have, that would be 4, 6, 8, 10, 12, 14, 16, 18, and 20. So this is the answer for B complement intersection A. B complements the set of all elements in B, but not in the universal set. We fetch them out. Then after this set of all elements present in the universal set, but not in B. I beg your pardon, please. And then we fetch them out, okay, and then we now try to look for the elements they have in common with A, and then these are the elements that the intersection of B have in common with set A, all right? So that the complements of B have in common with set A. So that is that as per that. So then we move to the next one. The next question says we should find A union B. A union B means the union of A and B, right? The combination of A union B complement. So the combination of the elements of A and B, okay, then we now find the complement of that combination. So which means if you want to find A union B complement, okay, to find A union B complement, what you do is first find A union B. That's the first step, okay? First find A union B. When you now get A union B, you now find the complement of that union. So that's how it works. So to find A union B now, we do that. A union B means the combination of all the elements of A and B. So what are the elements of A and what are the elements of B? So A union B will be equal to all the elements of A and B. They both have two, that will be 2, 3, 4, okay, 5, 6, 8, 2, 2, 3, 4, 5, 6, 6, excuse me. We have 2, 3, 4, 5, 6, then we have 7. We have 7. We have 8. Although the order of arrangement does not matter, but it helps you to be sure that you didn't omit anything. Okay, 8. No 9 in both of them. We have 10, 11. 10, 11. We have 12, 13. Then we have 14. No 15. We have 14, 16. We have 17. We have 18, 19, and 20. So this is a set of A union B, the combination of A and B. That is what we just fetch out. Then we now find the complement of that combination. So A union B complement will therefore be the set of all elements that can be found in the universal set, but not in this union. That is A union B complement, the set of all elements that can be found in the universal set, but not in this union. And so, then what are those elements? That would include 1, 2, 3, 4, 5, 6, 7, 8. That would, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So this is the answer for A union B complement, the set of all elements that can be found in the universal set, but not in the union of A and B. Okay? All right, so we move on to the next question. The next question says we should find A complement intersection B complement. So we have A complement intersection B complement. Right. So to find the value of A complement intersection B complement, we first find A complement. So we first find A complement. A complement should be the set of all elements present in the universal set, but not in A. And then those elements will be 1. We have them in the universal set, but not. That means set of odd numbers, because set A is a set of even numbers. So any number that cannot be found in set A would be odd numbers within this domain. All right. So let's do that. Then that will be 1, 3, 5, 7, 9, 11, 13. We have 15. We have 17, 19. These are like A complement is just the same thing as C. But then the question says find A complement intersection B complement. So let's find B complement. B complement is a set of all elements that is in the universal set but not in B. So what are those elements? You have 1. Okay, 1 is not in B, but it's in the universal set. 2 is here, 2 is here, 3 is here, 3 is here, 5 is here. Okay, we have 4. 4, we have 1, 4, 5, we have 6, 7, 8, 9, 10, 11, we have 12, 13, 14, 15, we have 16, 17, we have 18, and then we have 20. So this is a set of all elements present in the universal set, but not in B. So the next thing is now to find the intersection of the two of them. So which means A complement intersection B complement would be equal to what is common between these two. Okay? So what is common to the two of them? Let's check them out. 1 is here, 1 is here. So we write 1. 3 is here, 3 is not here. 5 is here, 5 is not here. 7 is here, 7 is not here. 9 is here, 9 is here. So we have 9. Okay. 11 is here, 11 is not here. 13 is here, 13 is not here. 15 is here, 15 is also here. So we have 15. Okay. 17 is here, 17 is not here. 19 is here, and 19 is not here. So which means that A complement intersection B complement is 1, 9, and 15. That is all. Okay? So then the last question, which is B intersection C. You could use this one to prove one of the theorems of all those axiomatic stuff, like, although we are still going to get there in subsequent videos, okay? Then we'll prove all of those things there. Now the last question, B intersection C. I think I can rub this off now. So B intersection C means the intersection, like these elements that is common to B and C. So B intersection C will be what you can find here and you can also find here. And so that will be equal to 2 can be, okay, 3 is here, 3 is here. 5 is here, 5 is here. 7 is here, 7 is here. 11, 11. 13, 13. 17, 17. 19, 19. So this is the intersection of B and C. And that is the end of this question. Hence the end of this class. All right, so don't forget the usual thing. Emostel Academy cares about your excellence. And there are steps towards this excellence. The step number 1 is for you to learn. Step number 2 is for you to understand what you learn. There is no point you learning without understanding. And that is why we are here for you, to simplify things, to make it easy for you to understand, so that you can be able to proceed into the third stage, which is practice. When you understand anything, you put it into practice. You try to solve as many questions as possible with what you understood, or you relate them with real life situations, or you use them to even solve problems in your various fields. Then at the end of the day, when you do all of these things, one thing is guaranteed, and that thing is excellence. In Emostel Academy, excellence is our priority. See you in the next video. Bye.